Year 6, this short little video accompanies your arithmetic learning for the 12th of the 1st, 2021. So hopefully you've had a go at answering the questions already in your jotter. If you haven't done that, you'll need to pause the video and have a go first. If you've already had a go and you found a question tricky, hopefully you'll find some support in this video. Don't forget you can always pause, rewind and replay these videos and come back to them at a later date if you need to. We're going to start by looking at the lower key stage questions. Then we will have a look at the Year 5 and 6 questions, and we're finished by having a look at the flashbacks. Okay, so let's make a start then with lower key stage questions. Question number 1. 634 add 62. Now there are two different methods you could use for this question. Some of you may have used the formal written method or column addition. And while that's perfectly acceptable and it will give you the correct answer, is there more of an efficient method that you can use? Have a look carefully at the numbers again. I think I could probably do this one mentally. Let's start by looking at the ones. I've got 4 and 2 in the ones column. And I know 4 add 2 equals 6. Now, if you find that a little bit tricky at home, you could always use some counters to help you. Marbles are really helpful, or toy cars, or chocolate buttons. Find something at home that you could use as a counter if you're finding it tricky. Try and be as resourceful as you can, Year 6. Here we are then. We have 4 add 2 equals 6. Now I'm going to have a look at the numbers in the tens column. Here I have 6 tens, or 60. And in this number, I have 3 tens, or 30. So 30 add 60 equals, that's right Year 6, it equals 90. And again, if you're finding it tricky, you can always use some counters to help you. At school, we use deans. At home, you could find anything you like to represent your deans. So I've started off with 6 deans, or 6 lots of 10, which is the same as 60. And now I'm going to add my 30. So 3 more lots of 10. 60 add 30. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 lots of 10 is 90. Now, if I was to combine these two numbers together, 90 add 60 is 96. Let's have a look at the digits in the hundreds column. So there are no hundreds in this number, only 62. But we have 100 or 600s in this column, 600. I've got nothing to add it to, so my answer is 696. Okay, let's have a look at question 2. 950 divided by 10. Now Year 6, you'll remember that if I'm multiplying or timesing by 10, by 100, or by 1,000, I can draw a place value chart to help me. And this is exactly the same if I am dividing by 10, 100, or 1,000. Place value charts will help with all of those calculations. And Year 6, you are really familiar with drawing these in your jotters and completing these calculations. So I have no doubt you'll be able to do the same at home. So here's my place value chart. Let's start with 950. I'm going to make sure I put the 9 in the hundreds column, the 5 in the tens, and the 0 in the ones. 950. Now I want to divide it by 10. Now, when I am dividing, I am making a number smaller. This means I'm going to have to move it to the right on my place value chart. That will always make the number smaller, or divide it. Now I'm dividing by 10. This means I have to move all of the digits one place to the right. Can you remember Year 5, our handy trick for how many places we have to move each digit? That's right, there is 1 0 in 10, so I am making it 10 times smaller, which represents one place on the chart. Now, you'll notice that we've moved into the tenths column, and therefore we have to remember our decimal point. This number becomes 95.0. Do we need to keep the 0.0, Year 6? That's right, we can ignore the 0.0, so my answer is 95. Let's have a look at question 3. 3 times 7. Now, if you find your times table tricky, don't forget that you can draw an array to help you. And an array looks like this. Again, you can draw these in your book by using simple dots, or you could find some counters, buttons, or even some chocolate buttons at home if you have them. Marbles are also handy. Let's have a look at our array then. We want 3 lots of 7. 1, 2, 3, 4, 5, 6, 7. So this is 1 lot of 7. And then we repeat. So we have 2 lots of 7 and finally 3 lots of 7. 3 times 7. Oh, that's a very wonky 7, isn't it, Year 6? I do apologise. Now we've drawn our array, we can count each button or each counter. 1, 2, 3, 4, 5, 6. That's going to take me a very long time. So if I can count in threes, that's quicker. 3, 6, 9, 12, and so on. Or I may be able to count in sevens. 7, 14, 21. 3 times 7 is 21. Okay, let's have a look at 20 divided by 4. Now, my 4 times table would help me with this question. I could write out the multiples. 4, 8, 12, 16, 20. Ah, that's right. I know 4 times 5 equals 20. Therefore, 20 divided by 4 is 5. Let's have a little look at the last one together. Question 5, which is 6 elevenths I'm getting my words in a muddle, Year 6. 6 elevenths subtract or take away 3 elevenths. Now I've written the fractions down here to help us. We start by looking at that bottom number, the denominator. And because they are the same, we know that they will be the same. It will be the same in our answer. That leaves us free. I've put add instead of subtract. Whoops. Sorry about that, everybody. That leaves us free to subtract our numerators, or the top numbers. 6 take away 3 is 3. So our answer is 3 elevenths. Now, a question we would ask ourselves if we were in school is, can I simplify? Is there a number that divides equally into both 3 and 11? What do you think, Year 6? That's right, there isn't a number, so we know that we have the smallest possible answer, the most simple answer. Okay, we're going to move on to have a look at the questions from Year 5 and 6. Now, lots of you should be feeling very confident with these questions, so we can move quite quickly through the answers and the modelling. Let's have a look at question number 1. 977 multiplied by 0 will be 0. For the second question, I'm assuming most of you probably did a formal column method. Let's have a quick look together. So I made sure I put my biggest number at the top, and I've lined up all the digits correctly. All the thousands are in line with each other, hundreds, tens and ones. 6 take away 3 is 3. 4 subtract 5. I will need to do an exchange to be able to complete this. 14 subtract 5. That's right, year 6. 9. 5 subtract 4 is 1. 5 subtract 2 is 3. And 2 subtract 0 is 2. Hopefully you all got that one right. Let's have a look at question 3. So you'll notice that these numbers have a decimal point in them. Therefore, we must make sure if we are to use the column method that we line up that decimal point accurately, that our tenths, hundredths, ones, tens and hundreds are lined up correctly. If we don't do this, we're going to get the wrong answer. Okay, let's have a look. 8 add 5. That's right, 13. 2 add 3 add 1. That's right, 6. Don't forget your decimal point, make it nice and clear. 6 add 8. That's right, 14. 7 add 3 add 1. That's right, 11. 1 and 1 is 2. 214.63. Okay, let's have a look at question number 4. I've set up the bus stop method here. Now I've only done this in purple year 6 to make it easier for you to see on the video. You don't need to use a different colour at home, your pencil will be fine. So we are working out 1210 divided by 11. And I can use short division to help me with this. Let's make a start. 11 into 1 doesn't go, so I put a 0 at the top and I carry the 1 over. 11 into 12 goes once with remainder 1. 11 into 11 goes once. 11 into 0 doesn't go. So my answer is 110. We're going to have a look at the fraction question now, number 5. 2/3 subtract 3/21. Now, straight away I've noticed that bottom number or the denominator is different. And before I can continue, I have to make it the same. Now, luckily, we all know our 3 times table. So we know that 3 times something is 21. Can you remember what it might be, year 6? That's right, 3 times 7 is 21. So I'm going to multiply this denominator by 7 to give 21. Now, whatever I do to the denominator, I have to do the same to the top, or the numerator. So I'm going to multiply the numerator by 7. 2 times 7 is 14. If I look at my second fraction, it's already got 21 on the bottom. Therefore, I do not need to change it. 14 subtract 3 is 11. And just like before, if the denominators are the same, they can stay the same for the answer. 11/21. Can I simplify? You're right, we cannot simplify this fraction. Can you tell me why? Okay, Year 6, we're going to have a little look at the flashback questions now. So we're going to start with the Year 4 questions and then have a look at the Year 6 questions. Just like earlier in the video, because I'm multiplying by 10, I'm using a place value chart to help me. I'm going to start by writing 72 into my place value chart. Now I am multiplying this time, so I'm making the number bigger. So I have to move it to the left. Can you remember how many places I'm going to move it? That's right, when we multiply by 10, we move one place to the left. What will I have to put into this column? Oh, Year 6, you may have noticed an error that I have made. Can you spot my error? That's right, I didn't put my digits in the correct place. Let's have another look. I'm doing 72 times 10. We need to make sure that the 7, which represents the 10s, go in the 10s column, and the 2, which represents the 1s, goes into the 1 column. Now I'm ready to multiply by 10. And just like you said earlier, we're going to move it one place to the left. Don't forget to put in your placeholder here. So the answer for question number 1 is 720. Let's remind ourselves then for question 2 what the perimeter means. Now the perimeter is the space around the outside of an object. We're going to calculate the perimeter of this rectangle. Now you can see that each square represents 1 centimetre. And therefore, I can count the squares to find out the length of this side. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 centimetres. What will be the length of this side? That's right, 3 centimetres. And because we know rectangles are the same length and the same width, we can complete the other missing sides. Now, to calculate the perimeter, we want to know what 9 add 3 add 9 add 3 is. Now I'm sure you've got lots of different ways of working this out, Year 6. 2 lots of 9 is 18. 2 lots of 3 is 6. 18 add 6 is 24. That's right. Can you remember what unit of measurement I will need to put on the end? Fantastic, Year 6. Centimetres. Okay, let's have a look then at the next question. Now, it's asking you to find the difference. You'll remember that difference is a subtraction. I'm sure you'll be able to find the difference between these two numbers mentally. 2,800 subtract 1,300. That's right, 1,500. And finally, question 4. We're going to calculate 1/3 of 18. Now remember, if you want to find a third, it is the same as dividing by 3. So 18 divided by 3. Use your 3 times table to help you. 3, 6, 9, 12, 15, 18, 6. You know that 6 times 3 is 18. Okay, Year 6, our final part of the lesson, we're going to look at the Year 6 flashback questions. Let's have a look at question 1. Calculate 6,587, subtract 1,999. I'm going to do this one mentally. I can round 1,999 to 2,000. I can subtract 2,000 from 6,000 mentally. I'd be left with 5,587 plus the one that I used for rounding to give the answer 5,588. Let's remind ourselves now how to round in question 2. Round 8,888 to the nearest hundred. Now, if I'm rounding to the nearest hundred, I start by finding the digit in the hundreds column. Ones, tens, hundreds. 8. Now I'm going to look next door. 0, 1, 2, 3 or 4, I would stop and stay the same. 5, 6, 7, 8 or 9, I would round up. So I have an 8 next door, which means I have to round the 800 to 900. All the other digits stay the same. Sorry, Year 6, I've forgotten the rhyme there, haven't I? Let's go back. So we round the 8 to 9. All digits before stay the same, and all digits after become a 0. Let's have a look at question 3. We need to use our place value knowledge to work out the missing number. So I have 6,900,000, 80,000 and 1. What's the missing number? Well done, it's 900,000. Make sure you've got enough zeros. 900,000. Let's have a look at question 4. A TV programme lasts 90 minutes. Okay. It starts at 13:45. What time does it finish? Now you'll notice that I've underlined the key information, and you'll remember that we use U, D, C to help us with a word problem. So I've underlined the key information. Now I'm going to think about what I could draw to help me. It might be useful to draw a clock, which is quite tricky on the computer screen, so I'm sure you've probably done a better job than me. So it is 1:45. Now I know some facts about 90 minutes. I know that 90 minutes can be broken down into 1 hour, which is the same as 60 minutes. It can also be broken down into half an hour, which is the same as 30 minutes. 60 add 30 will give me 90 minutes. So I'm going to start by adding an hour onto my time. So the time would become 14:45 or 2:45. I've added the hour on. Now I need to add my 30 minutes. I know I can do this by counting round my clock till 3:15. Again, my clocks are quite tricky to draw Year 6 on the computer screen. I'm sure you'll do a much better job than me. So I've added on my 30 minutes. And the time is, that's right, 15:15. Don't forget, for time you need the 2 dots. They look a little bit like a colon. And there we have it, Year 6. There is your teaching and support video complete for the 20th of the 1st, 2021. Have a wonderful day and I will speak to you again soon.